So first we learn about in theory of equation. We first learn square root. Then we learn about complex numbers. So first up क्वेश्चन इन आवर माइंड कि हमारे माइंड में क्या क्वेश्चन आता है कि स्क्वायर रूट क्या है। जब हम इसको समझने की कोशिश करते हैं कि यार स्क्वायर रूट क्या है, तो सिंपल देखो, अगर मेरे पास कोई एक p है जो एक पॉजिटिव इंटीग्रल वैल्यू, सपोज ये पॉजिटिव नंबर है 0 से लेके इन्फिनिटी तक, बस एक पॉजिटिव इंटीग्रल है, ठीक हो गया। तो जो इस साइन में ये जो हिस्सा ये यूज़ करते हैं हम, इस रेडिकल साइन को ही बोलते हैं स्क्वायर रूट। इसके अंदर जो भी p है, ये p जो है वो p बिलोंग करता है 0 से इन्फिनिटी के बीच में। ये इंक्लूडेड है, इंक्लूड इन्फिनिटी तो क्या इंक्लूड होगी भाई, वो तो बढ़ते रहता है। तो means that if p is an integral, okay, from 0 to infinity, then the sign of this is called square root of this p. Okay, a major problem we faced in if p belong to minus infinity to minus 1, I means less than 0, then what happened? Means if p belongs to minus infinity to 0, then what should we do? This problem, how we solve this problem? So then a mathematician introduced the sign iota, okay, which is nothing but it is equal to minus times of this, and the square of this is also minus 1. Since when we talk about a minus of 2, we can also say that it is the minus times positive of 2. So that's why iota, this minus sign is called iota, and root of minus 1, and this is square become minus of 1. So this, from this, why this we use iota in the terms of minus 1, because if we have under root of minus 1, it is nothing but it is 4 times under root of minus of 1, it is minus of 1. And also if we have a minus 4, which is nothing but it is a minus 1 times 4. So 4 is positive, but this is a not, it also we call that. So that's why we use the minus 1, we use the word iota in terms of minus 1, and the square of iota is 1 minus. And for example, if we have x is equal to minus of 1, then the roots of this is iota times into minus iota, because then both of square is become minus of 1, means iota square is also minus of, which is also equal to minus of 1 minus iota square. So that's why we call this, sorry I goes wrong way, okay, this way, okay. So if p is a positive number, we say, means another thing, that if p is a positive number, then x is equal to minus p, which is nothing but it is, so simply that you see you see minus p are nothing, this is minus 1 times p. Here we see that the minus 4 are nothing, it is the minus 1 times 4, and the x square is equal to minus of 4, which is nothing but is a minus 1 times 4, which is minus 1 in the under root of 2. So it is 1 under root of 4. So what should mean? We mean x square equal to minus x equal to plus minus of under root and minus of 4. Okay, this is minus of 4. So this is 2, but this times is iota. So x is nothing but plus minus of 2 iota. You understand? Means again we explain that this is a x square minus of p is nothing but it is the x square of minus 1 times of p. Okay. So when now what is the value of x? Means how the x will come equal to minus of p x square, it is the p and minus of p. Both should call what is the roots of this solution? Okay, so plus minus under root of minus 1 into under root of p, because this is a positive number. All negative numbers Rn positive is a minus of n, which is a negative number, but nothing. It's a minus 1 times of p. Minus 1 times of n, which is a positive number. We also call that. So x equal to minus 1 times p, and then this is all iota. So plus minus of root p iota. So that's why we called under root of p iota and plus minus. P is a positive number, okay. And a simple theory in our mind that if we use this is x is equal to minus of p, we denote this. So why should we not denote in the form of minus p? This is the also form, which is also the minus 1 times p is equal to p iota. So why we use only p iota rather than of minus of p? Why? So a simple theory that we even if we totally means sometimes we confused about what is the minus of p. For example, so why we use minus of p in rather than of why we use p iota rather than of minus e? This is also true. Yes, it is also true, because this is also true means it has also minus p. This is also p. This is also complex number. This is also not complex number. This is also complex iota form. This is also iota form. So why we use this, and this is not why we not use. One question is out of in my mind, so think that. I will pause. Think. Let's see. Take a little example. This is the minus p. Let square that. Means square means what? Means this is multiplied by 2 times. Okay. Means this is the minus p, and this is also minus of p. When you multiply, this is the square of minus of p. Okay. According to this, and we took this both sides. If minus of p, which is under root of p into iota whose square, and again this is the minus of root p, which is square, means minus of p and minus of p. Here we see the clear difference about that. When we talk about that, it is what? It is the p. Sorry, it is the p square of this p and iota square. Okay, and it is what? It is. Let's see. This is p into p into minus of p into minus of p. Okay. Minus times plus, this is a p square with the root, and this is because of p iota square is negative. This is minus of p, and this is p. So this is the contradiction. Not that if we took this and we took the square of minus of under root p, it becomes positive p. But in our question, this is the minus of p. This is the x is equal to minus of p. So when we take great square, not give the original answer. So that's why this is the error, and to solve this error we use this, and simply you understand that it is very easy. So this is also correct and this is wrong. So that's why we use okay. Now we talk about what is the complex numbers. This is the theory of iota sometimes. Okay. Now we talk about the what is the complex number. Okay, this is the talk about complex numbers. Okay, and this video, let's talk about complex numbers. If it's normally we understand that the a plus b iota, it is the complex number where a's and b's are real. Okay, so this is the definition. Okay, means what is the complex number? What is the complex number? If let's understand, we have there are, if a and b are two real numbers. Okay, that is if there are two real numbers, and iota square is equal to minus of 1. Then a plus bi is called a complex number. Simply say that. Okay, this is the complex number. Okay, that means little summary, that is a plus b iota, it is the complex number. Okay, and the conjugate, what is the conjugate? This a plus a minus b iota is the conjugate of a minus b iota. Conjugate means when we add them, it vanishes, the complex number vanishes. Story. Okay. It is the conjugate. Just 1 second. My hand is stuck. Okay, there. See that? Okay, so means a plus bi is this, and the conjugate of this is a minus of bi. Okay. Now we talk about two complex numbers are equals. Okay, this is the complex number 1, c1, say c2, it is the another complex number of ti. So when the two complex numbers are equals, okay, and think about that, what is the conjugate and what are the role of this. Okay, let's think about in next video we talk about what is the conjugates. But in this video a question of this is to solve what is the conjugate, okay, and why this talk about conjugate. Okay, so think about that, what is the conjugate and why we use. Okay, why the conjugate signs are minus, why, and think about that, what is the conjugate. Okay, now a new topic. Two complex numbers are equal. When the two complex numbers are equal, think little bit idea about that. When this is equal to this, if let's think, if a is equal to c, that is the real part of the complex number is this, and b and c, that is the imaginary part of the complex number, is also equal, then the complex number are said to be equal. Okay, one little bit thing, right? We talk about that a complex number is made by a real or imaginary part, where a and b are imaginary. Okay, means simple that. Another question is why the complex number is the form of a plus bi. Why? Think about that. Why this? And a complex number, why? Think. And next question, another thing that okay, we talk about iota. Okay, then this are two questions. Next video we keep this answer, but think about it. Why? Let's think. Okay, means the two complex number are equal. If a equal to b, that means the real part is real and imaginary part equal to b. That means the two means are equal, then both face and clothes are equal. Then to say to that this is and this is are equal, no difference. So means this is the face and this is the body. So the real part of the complex number is equal to real part. Okay, so real equal to real part numbers, and imaginary. Okay, imaginary equal to imaginary of 1 equal to imaginary of 2. Not square, this is 2. Okay, let's think about, we have a complex number a plus or bi. What if a equal to b equal to 0? What mean? If a equal to b equal to 0, let's think, a 0 iota. Oh, this is the 0, this is the 0 into anything infinity, rather than infinity would be 0. This is 0 plus 0, this is also 0. So this is the, that is the complex number has become 0. If real part of is 0, if the real numbers are 0, then complex numbers are 0. So I think that 0, a number, which is a number, but it is, we also call that 0 is equal to 0 plus a iota. 0 complex number. I think the all complex numbers, let's talk about further. Okay, if we talk about in previous that if a equal to b equal to 0, then its complex number is 0. Okay, another thing, what if a equal to 0 but b is not equal to 0? Case 1. If a equal to 0, b equal to not 0, think. Let's see. This is the complex number. Okay, we talk about if a equal to 0 but b is not 0, then what 0 plus b iota. Oh, this is the b iota, so this is only complex number. Here we see. Okay, means it is a imaginary, that is this complex number is imaginary. Iota is imaginary. Iota imaginary. Iota imaginary. Synonymous. Okay. That means it is a purely no real value. Okay, although it is 0, but in the way no role of 0, so bi is equal to, it is purely no artificial, purely imaginary. Okay, purely imaginary. 100% purity. Okay, 100% yield. In chemistry yield, we talk yield, purity. There is the 100% purely imaginary. 100, not GST. 100. Okay. Think again. Case 2. What if b equal to 0 but a not equal to 0? Let's see. This is the complex number. Okay, here we see that a is not 0 but b is 0. Let's put a not 0, which is not, and b is equal to 0 iota. This is sign times multiplied by 0, which is 0, so become a. So this is a. This would get, although is this, but is no value of this 0. So what is the value of a? What is a? This is the root. This is the real part. So this is the real, and also we called real, purely real, 100% pure. Okay. So let's talk about, we call that, we further talk about that. We say that all real numbers, all integers are is the form of this plus of this. We also say that this is the purely real part, but this is integer, also called as real number. So this integer is the form of this. Also we call that by integer. Real numbers is the form of r plus of 0 iota. We talk of integer and this. So this is the real number, and this is the form of this. All purely real numbers in the form of this. Also 0, this. Okay. We can say that easily. This is the form of this. Okay. So now we talk about the addition of two complex numbers. Addition of two complex numbers. Okay, let's talk about the how we once again talk about that how we add the two complex numbers. Sorry, we missed this. Okay, so simple that we have a complex number 1, another complex number 2, no, x plus yi. Okay, let's think. So this is the complex number, so now we add. Normally this is nothing but this is this, and this is x plus of y iota. Okay, means a real part add real value and the imaginary part, add imaginary part. Okay, that is a plus of x plus of b plus of y iota. This is called a adding of two complex numbers. Means the real part of the complex number 1 add the real part of the complex number 2, which is the real part of the 1, real part of the 2, and the complex part of imaginary part of 1 and imaginary part of 2 add. Okay, think that we have a real number and the imaginary. How we add this? The imaginary part. So how we add this? So means the real part are real and the imaginary are imaginary. Okay. Next video we talk about, let's see, another number, that search about history of complex numbers. Means कि what is the basic idea of why we talk about complex numbers. We have real numbers, natural, but why the mathematician who create complex numbers, what is the idea of that? He thought that let's create a complex numbers. So think about that, history of complex number and idea of the complex number. Means that who created the complex number? What is the idea of that he created a complex number rather than it is all infinity complex number or infinite numbers. So why the idea of the complex numbers are thought in this mind? Let's think about it. And another thing that then think and little bit in my mind. Okay, that's the idea of the complex number. What is his thought? Okay, and then the journey of this. Okay, what is the journey to make a complex number? But this is the not important, but this is more important. This is also more important. Okay, so the idea of the means how the idea has come. Okay, and next you think about that. Because you search about that and you think about that, the idea of the complex number, and next that can you think about a new way to find a complex number type. Means can you think that we learn about complex numbers, can you further think about a new way to understand a complex number or to new things? Okay, you understand what should you mean? How I see. This question let's drop. We talk about later about this question. Okay. Okay. Now subtraction. Okay, subtraction. Okay. It is the inverse. Nothing is the inverse of addition. Okay, means this a plus b iota. This is the complex number. Can you think how the complex numbers are made. Simple idea that we have a complex number this, another complex number of this. When we add them, let's think the complex numbers are fine. So the complex number which is we add, this is we find by subtraction of x plus of yi. Okay, and from the addition this is nothing, it is the real part minus real and imaginary part imaginary. Always think that okay, the z is equal to this, and a minus x, the real part minus real and imaginary part minus imaginary. Okay, and multiplication. Okay, the two complex numbers multiplied. Let's see, that is a plus of bi and x plus of yi. So first a multiply by this, and then b multiply by this. So plus b iota into y iota, then a multiply by this, a into y iota, then b multiply by this, b iota. This is complicated, but practice makes man perfect. All perfect. Man's come v1v. So ax minus iota plus by iota square, and ay plus of bx iota, and ax iota square minus iota square equal to minus of 1. This minus times by plus ay plus of bx times iota. Okay, this is the multiplication of a plus bi into x plus of yi. Hence proved. Okay, so this is the multiplication, and now we talk about division. Okay, let's talk about once again division in complex number. Okay, oops. Okay, nothing, it is also inverse, means this is the a plus, this is the x plus of y this case, and number is multiplied by z. Okay, as an we'll okay, this is also a, but and previous and multiplied, this is a plus of bi. So now this a plus bi will come, also this is maybe also correct, but normally both way. One, if think that this how I come, this a number complex number is this multiplied by this and this, so this complex number is, you understand that? So we find a new complex number in division. We find a new complex number z dash. Okay, means a complex number 1 is multiplied by the new complex number, and from this, and so we find in division this complex number. Okay, complex number multiplied by this, so we find this complex number. Okay, so this z dash is equal to a plus b iota into x plus of y iota. This is method, and with a little trick. Okay, let's prove. Okay, this is the a plus of bi and x plus of yi. Okay, multiply both sides by its conjugate. Okay, x minus of y. Okay, and this has become a multiply. Okay, so we call this ax. Okay, and then plus of bi into minus times of I. Okay, and then this also a square plus b square, but here we, okay, this is a plus b, a minus of b, then a square is a plus b into a minus b, a square minus of b square. Okay, then this multiply, and this and then this, which is minus times plus a times minus of y into iota, then plus of bi into x, this, and this become ax plus of minus plus minus iota square, and iota square is 1, this is minus 1, this is minus plus, and by upon x square plus of y square, and minus of ay into iota plus of bi into x. So this become ay plus ax plus of by upon x square plus of y square, then plus b iota x minus of ay into iota bx minus of ay times iota, this is x square plus of y square, also be this that ax plus of by into x square plus of y square plus of bx minus ay plus y square iota. Work in b, and the iota is middle, and so it means a number, this is x plus of y upon z, a number is a written in this, it means is x plus of y upon z multiply by whole time. So avoid this bracket, we also in the way of direction this. Okay, this is the way. And number 2, nothing, it is here 2, and here with x by y, and the x square y square, here the x is become and a is there. Okay, so the trick, okay, that always by a long method, simply saying that a plus of p iota upon x plus of y iota, simple, x multiply by this plus y multiply by this, okay, a x plus p y upon both square, add summation of both square and add, okay, then plus x times this x b, okay, iota minus y times this, am I right or wrong? Okay, sorry, x times this minus y times this, sorry, y times this minus y times this, okay, and square of both sides, this become ax plus of by into x square plus of y square, and xb minus of y upon x square plus of y square into iota. Think again, means a plus of pi, my writing is very beautiful, pi and x plus of yi, okay, nothing, first multiply this, then add this, okay, with this in plus of sign, okay, and if the plus a minus be plus into minus of this, okay, and then x multiply by this and y multiply by this with a negative sign in the p middle, okay, there go, x multiply by this a plus or y multiply by this by, and then square of both sides plus x multiply by b minus y multiply by a, and x both of, okay, think that multiply okay, and one thing upon x square plus of y square, okay, the denominators square, individual square and add, okay, this is the complex number. And another thing that the complex number x square plus y square if 0 means x is equal to y is equal to 0, so think that the complex number is not equal to 0, sorry, okay, so if this is equal to 0, then division is not possible, because division of any number by 0 is not possible, undefined, say 0 to 0 is 0, so how we define it? So okay, in next video we talk about why division is 0, not division is Okay, so in next video we talk about division of 0. Why not allowed if we have a time. Okay, here means if this is 0, division not allowed. So except 0, the complex number is divisible by all numbers. Okay, and also we call that is for to allow the division of x square by two complex numbers and find new complex number, that x plus y square is not equal to 0. This is the condition, and means that the except 0 is available except 0. Okay, divisible by all, but all all complex numbers except 0 complex number. Okay, sorry. Except all complex divisible allowed by all complex numbers except 0 complex number. Okay, this is the main heading of that. Okay, division is not allowed. Okay, and both way, if means we talk that if x is equal to 0, then division is not allowed. So condition is that the denominator not equal to 0, means division all allowed, all complex, anyone, but one thing that is not a 0 complex. Okay, so here it, and one second, here the note this. Okay, here the note we just talk about the if p positive, then the square root of this is this, and we face the problem is a negative number, and this is the main we talk about that. This is the complex numbers which talk about, and this, okay, this addition, multiplication and division. Okay, this, okay, this, okay, and next video we talk about cube root unity, and then further we go. Okay, thank you, bye.